let's create this bottom plate in CATIA design. So for that, just we'll enter into start new part design. So while entering into part, we are going to create here bottom plate. So just we'll give part name bottom plate, will specify as like this, and let's say okay. Now to create this bottom plate, we are having this base with a length of 250 and width of 151 rectangle. It should be with a thickness of 30 mm. So just we'll go here with position sketch on this top plane. So to make it proper orientation, I will use swap reverse vertical. Let's say okay. So on this top plane we are having here center point rectangle. So just we'll create one rectangle exactly with reference to this origin. To give dimension, we will go for constraint. Dimension for this we are having length of 250. Then width we are having for this as 150. Exit workbench. So with this profile we need to make pad with width of 30 mm. Let's say okay. Then next to that we are having one center hole here with a diameter of 50. Exactly with reference to on this vertical axis. From here we are having with a distance of 50. Now to create hole, we will go here with hole on this face. So diameter we need here 50. Depth should be up to next. So to make this hole proper position, we will go here with positioning sketch. Then by using constraint, this point should be exactly on this horizontal axis. Let's make it coincidence here. Then from this end to this point, we are having here distance of 50. Then exit workbench. Let's say okay here. Center hole is created now. Then same like that, we are having here 4 holes with a diameter of 25. Depth up to next. For position horizontally we are having 30. Vertically also we are having 30. Now we'll go for hole. One hole we need on this face with a diameter of 25. Depth up to next. So to make it position, we'll go for positioning sketch. By using constraint, dimension from this point to this end we need here 30. Then this point to this edge, vertically we are also having 30. Exit workbench. Let's say okay. Now by using this original hole, we need to create these multiple holes in linear movement. In that condition, we can go here under transformation features. We can use rectangular pattern. So first direction we need this side. As we can see, distance we are having here 90. So just we will give 90. Total 2 holes we want in reverse direction. Same like that here also we want. We will go for second direction. Instances we need 2. Horizontally we are having gap, we are having 190. So let's give this 190 dimension. So direction is with reference to this we need, or else we can select this axis system also. Let's say okay. So like this we can create this bottom plate. So if you want to change some color on part body, mouse right click, we'll go here with properties, then we'll go here with graphic, and we are able to give whatever the color we want. Let's apply this color and save it in a separate folder. So just we'll create one folder here. So assembly design I'll create. So we need here press tool assembly. Just I'll open press tool assembly. I'll save it as bottom plate. Let's save here. Next we'll create this top plate. So to create top plate, we'll enter into here new part. So we need here top plate. Let's give that part name. Then let's say okay. Same here. Before we have created for bottom plate, same parameters we are having here. One rectangle we need with length of 250 and width of 150. It should be with a thickness of 30. So again I'll go here with position sketch. So we need on this top plane. So to make proper orientation, swap reverse vertical. Let's say okay. Now we are having one center point rectangle here. To give dimension, we'll go for constraint. Length we need here 250 and width we need here 150. Then exit workbench, make this pad with width of 30. Then next to that, before we are having hole here for bottom plate, but now material is added with length of 90, with same diameter of 50, with same position exactly on vertical axis. From here to here 100, or else from this end to this we can take it 50. Now we need to create one sketch on bottom face. So here we will go for sketch. Then we need one circle here exactly on this axis. Dimension for this we are having diameter of 50. Then to make this position, this center point to this edge we are having here 50. Exit workbench. With this shape, material should be added. So we'll go here with pad. So we are having length from this to this total 90. Let's give this total length of 90 like this. Then next to that, top we are having 4 holes with a diameter of 40. So like as we have did yesterday or like before, just we will create one hole on this face. Diameter we need 40, depth up to next. Then to make proper position we'll go for position sketch. Same here also, horizontally we are having 30, vertically we are having 30 as we did earlier. So this to this we need here 30. Then same from point to this also we need here 30. Then exit workbench and let's say okay. So by using this original hole, again we need to create 4 holes by using this rectangular pattern. So we need to, in first direction we are having distance of 90. Let's give dimension of 90 with reference to this direction. We need reverse direction. Then second direction we need to, with the distance of 190 with reference to this, we will make it here reverse. Let's say okay. So just we will apply some color for this. I will apply some color for this. Then we will save this as top plate. Under same press tool assembly only we need to save. Just we will save this one. Then I will close this. Then next to that we will create this guide pillar. So again we'll go for start part design. We need here guide pillar. Let's give part name and say okay. Now to create guide pillar, we are having one circle with a diameter of 25. Total length we are having here 200. So just for example on the top plane, I'll go for sketch. We need one circle with a diameter of 25. Exit workbench. Make pad. Total length we need here 200. So let's give total length of 200 like this. Then at end we are having here chamfers with a length of 2 mm into 45 degrees. So directly we can go here with chamfer for only this edge and this edge we need to select with a length of 2 with inclination of 45 degrees. Let's say okay. So let me apply some color for this also. Just we'll apply some color for this. Then we'll save it in the same folder, guide pillar. Let's save. Then next to that we are going to create here guide bush. So to create guide bush, we are having one circle with a diameter of 40, one more circle with a diameter of 25. It should be make pad of 60. Then at both edges we are having chamfer of 2. Now let's go for new part. We need here guide bush. Let's give part name. Then on this top plane I will go for sketch. Just will create some 2 circles here. Dimension for outer one we are having diameter of 40. For inner one we are having diameter of 25. Exit workbench. Make this pad with width of 60. So let's give width of 60 here. Then we will go for chamfer. We need to apply chamfer for only this outer edges with a length of 2. Let's give that chamfer and let apply some color for this too. Just we will save it in the same folder. Just save it as guide bush. So like this we can create all the parts related to this press tool assembly. Now let's create this press tool assembly design. So with whatever the parts already we have created in earlier tutorials. So now, so to create that, just we will enter into start mechanical design. Then already we have created parts and we have saved it in one separate folder. So to call that parts in assembly design, we can go here with existing component. Just click on the product. Now, according to this assembly, I need to start with this base part. So just I'll select here bottom plate. Let's make it open. Then whenever we are going to design an assembly design, always one base part will be fixed. So to fix that part, as we can see here under constraints toolbar, we can use this fix component and we can click on the part. So as you can see, this part will be fixed here. Then next to that, we need to call this guide pillar. So to call that guide pillar, we can use here existing component with positioning. Why I am not going to use this option means, so if I use the same option, for example, I will call this guide pillar, that exactly it will come and settle here. But we need to move this part somewhere outside. So in that conditions, so we can use here existing component with positioning, click on product. Then we need to call guide pillar, let's say open. We are able to make proper position somewhere here outside. Let's say okay. Then this guide pillar we need exactly for this all four holes. So in these conditions, for example, same guide pillar we want for all these four holes, we need to assemble this main part to the original hole. It means these four holes already we have created by using rectangular pattern in part design. So if you want to use this same guide pillar at all four holes at a time, we can use one option called reuse pattern here. So to use this option, first original element should be assembled to the original hole. Now let's check which is the original hole. So this is the bottom plate. Just we will open here, again here plus, again click on here part body plus. So before pattern, whatever the hole we are having here, this is the original hole. So we need to apply relations only for this original hole now. So to make here properly constraint, we'll go with coincidence constraint. Just turn off this pop-up and say close. Relation we need between axis to axis, we need coincidence. Then after applying relation, we can have it here update option. So just we can click on this, or else manually we can use Ctrl plus U as shortcut key. So just make it update here. Then next to that, this downside face, it should attach with this bottom plate bottom face. Again I'll go here with coincidence constraint between this face to this face. So we need here same direction. If I keep it opposite, guide pillar will get reversed. So we need here same. Let's say okay and update. So properly it will settle at that part. Then here rotation will be there for guide pillar. So to check that rotation, on guide pillar mouse right click. Under delete we are having guide pillar object. You can check here component degrees of freedom. If I click here, we are having rotation with reference to this Z axis. So to lock that rotation, we need to use here angle constraint. Then rotation we are having with reference to Z axis. So to apply parallelism relation, we are going here with angle constraint. We need to select the plane which is having relation with Z axis. Means either you can select ZY plane or ZX plane. For example, I'll select this plane. So this plane, it should be similar to this parallel. So let's make it here parallelism. Say okay. Now for the guide pillar, if we check here component degrees of freedom, as you can see, there is no degree of freedom. It means this part is not able to move in any direction. Properly this part is fixed there itself. Then same guide pillar we need for all these three holes. So as already we know that all three holes we have created by using pattern. So directly we can go here with reuse pattern. Component is this. Then here two types we are able to see. Pattern definition means multiple guide pillars we are able to get here, but relations whatever we have applied for original one, it will be not copied and pasted here. So in this condition, we won't use this pattern definition. We will click on generated constraints. So generated constraints means whatever the relations we have applied for this original part, along with this part, constraints also will get copied and pasted wherever we want. So always we need to use generated constraints. Then component is this. We need on these holes. Let's say okay. Now if you check for any part degrees of freedom, it will show there is no degree of freedom. So this is the proper way to create this assembly design. Then next to that, I am going to call this top plate. So by using existing component with positioning, just we'll click on product. We need to call here top plate. Just I will adjust somewhere here upside. Let's say okay. Now same here we need coincidence. As we can see from top view, just I'll change here top view for better understanding. Whatever this edge face we are having, it should be exactly connected with this edge. So just we can select this face and this face. It should be on same direction. Let's say okay and update. So from top we got proper shape. Then again if I keep it here front view, in this direction we need this face and this face should be straight. So just we'll select this face to this face, make it here same direction coincidence. Then next to that, this top plate, it is able to move in up and down direction. As you can see with reference to Z, it is able to move up and down direction. Now as you can see here with reference to this assembly design, we are having gap here. So whenever we want to give dimension between face to face, in that condition you can use here offset constraint between this face to this face. Let's say example some 250 dimension I'll give and I'll make it update. Later we are able to edit this. Then let it be aside. Now for this top plate we need to assemble this guide bushes also. Again existing component with positioning under this product. We need here guide bush. Let's open that. Then same I will drag and keep it somewhere here. Here also we have created only one original hole and remaining we have created with pattern. So first we need to check which is the original hole. So for this top plate I will click on this plus part body plus before pattern. This is the original hole. So we need to apply relations for this guide bush to this original hole. Same we will repeat here. Coincidence between axis to axis update. Again coincidence between this top face to this top face will select same direction update. So to lock rotation we'll go for angle constraint. Rotation is with reference to Z axis. Just I'll click on this plane to this plane. We'll make it here parallelism. Let's say okay. Now if I check degrees of freedom for this part, here there is no degrees of freedom for guide bush. Now same guide bush we need for all these three holes. Directly we can create here reuse pattern, generated constraints, guide bush for these holes. Let's say okay. Now later according to this should be visible properly. So I will double click on 250. I'll make it here some 120 length and let's make it update. So proper position we are able to see here like this. Then as you can see for this assembly we are having axis systems and constraints are visible. So we'll get little like confusion here. So to hide all everything at a time, in specification tree constraints mouse right click, we can hide all constraints at a time. Then if you want to hide all axis systems at a time, go here with Control plus F. Then in this pop-up workbench we need to select here part design. Type we need to select here axis system. Then here search and select we need to click. Then here hide or show option will be there. Just click on this. At a time all axis systems will be hidden. So in this way you can create this assembly design. Like I have created this assembly design. Now let's see how to make this press tool simulation. So this top plate with this guide bushes, it should move up and down direction. So for that already we have arrested degrees of freedom for single individual parts. Like for example for top plate also in this moment we want movement. So in this direction we have given offset dimension. Now just I'll go with constraints. So we'll check here with offset dimension. This is the offset we have given. Let's delete that. So if this offset is there, this top plate it won't move up and down direction. We need to delete that. Then just I'll minimize this. So to make it simulation, we need to go here with start, digital mockup. Here DMU kinematics you can get one workbench. So just we will click on DMU kinematics. Now this is the interface of DMU kinematics. So just I'll drag these toolbars out. So we are able to get vertically. If you hold shift and drag, we are able to make it here horizontally. So just we need here these two toolbars. Then now we are going to make here first option fix. So first we need to fix the base part. So I'll go here with fixed part. Then we are able to create here new mechanism. If you want, we can change mechanism name or else let it be, no problem. So just I'll keep it as mechanism 1. Let's say okay. Then fixed part, we need to fix this bottom plate. Just I'll click on that. Then bottom plate will be fixed. Now to apply these relations, we need to go here with this DMU kinematics toolbar. Here we are able to see different type of joints will be available for us. So here first we need to go here with rigid joint. Rigid joint is nothing but one part and one more part, exactly it will fix to that and it won't move side by side. So now we need to fix that. So just let me go here with rigid joint. So to use continuously, I will double click on that. We need to fix rigid between guide bush to this top plate. Let's say okay. Again same this bush to top plate. Okay. Then again bush to top plate. Okay. Same like that for this bush to this top plate also we need to make rigid. Now if we move this top plate, along with that guide bushes also will move up and down directions. Now to give that up and down movement, linear movement, we will go here with prismatic joint. Just we will click on prismatic joint. Then line 1 we need to select any this edge we can select. Then line 2 for the second part I will click on this. Then plane 1 I will select on this first part plane. Again plane 2 is this. Then length driven should be turned on. So if it is turned on, then only this top plate will move in up and down direction. Let's turn on length driven and let's say okay. One pop-up it should come as the mechanism can be simulated. If you get this pop-up, then your joints are correct. Now let's say okay. So to check that simulation, so just I'll close this. So to check simulation, under here DMU generic animation, first option will be having here simulation. Let's click on simulation. Then we need simulation for mechanism 1. Let's say okay. Now we are able to get here two pop-ups. Just if I scroll this part is able to move in up and down direction like this. So here as you can see, this top plate is able to move beyond that limits. Then again it is overlapping to this bottom plate. So to make it proper relations, let me check dimensions first. For example, I need movement up to here. So we are having -20. Then in positive side, we need only up to here. So here 84. Let me consider some 80 here. So to check these limits, just we'll cancel that. Now in specification tree, we need to go for applications. Open here mechanisms. We are having one mechanism. Under that we have joints. Here these four are rigid joints. We need to change limits for prismatic joint. Double click on that. Minus value we want here only 20. Positive side we want total 80. Let's say okay here. Then just I will minimize this. Now again we will click on here simulation. Then for mechanism 1, let's say okay. If I move this, maximum it is moving up to here, whatever we have given limits. Then downside also maximum we given 80, up to 80 only it will be moving. So just I'll move like this and always try to maintain this cursor on positive side. Then go for insert, animate viewpoint. Here we are able to change movement, like if it is loop mode, only in one direction it will move and it will stop. Second one, two arrows you are able to see here. If we keep like this, it will move up and down direction continuously. Then again if I click this one more, two arrows we are having on one side, again the same operation will be repeated continuously. Now we need repeated on both directions, like it should be going upside and downside, like reciprocate motion. Then we are able to change here speed. Let me keep this speed as some 0.02 and let's make it here play. Now as you can see, with the given speed, with beyond this given limits only, this top plate with guide bushes, it is able to move in up and down direction like this. So if you want to increase speed, just we can increase the speed also. So this is very fast. So just I'll make it some fast like this. So in this way, we are able to create this assembly design and we are able to give this joints and we can make it simulation like this for better visualization understanding. So thanks for watching. Keep supporting. If any doubts related to this or if any improvements are other than this if you want from my side, so let me know in comment box. Once again, thank you everyone.